So now we're going to start off with basic bet sizing theory, and once again, feel free to skip this if you feel like you already probably know this stuff. Let's start out with the most useful bet sizing theory I've come across from Mathematics of Poker by Bill Chen and Jared Inkenman. We want to bet an equal fraction of the pot on each street when we have a perfectly polarized range that allows us to get all the money in the pot by the river. So an equal fraction of the pot where we're felting all in by the river. This is summarized on page 248 of the book, and probably the single most valuable piece of information I found in the book. And then a quick plug for the book. While this book is a pretty tough read, anyone very interested in poker theory will likely greatly enjoy this book. In my opinion, it's probably the most advanced poker book ever written by a very wide margin, and it's not something that you can just read and immediately apply it without thinking, but it is, in my opinion, also the most impressive poker book ever written, at least of all the poker books I've read. Deriving this solution requires calculus and a very strong understanding of math. This sizing structure maximizes the amount the bettor wins. While we get less folds than other bet sizing structures, we maximize how much we overall win. And that's what we care about. So, don't worry if you don't completely understand why this rule works, or if you don't understand how it was derived. Most people don't. But you can understand how if you have a range of nuts and air, you want to get all the money in by the river by betting an equal fraction on each street. An equal fraction of the pot on each street. For example, just jamming on the flop will get more folds if we risk $100 to win $10, since the opponent can fold over 90% of the time, since we risk so much to win the pot. Yet we'll win a lot more if we bet the flop in turn and make the opponent fold the river, because now when our opponent folds on the river, we've built up the pot. So, once again, it's a little bit complicated to derive this, but this is the most mathematically effective way to bet when you have a polarized range. Equal fractions on each street continued. A clairvoyant game means a player has complete information. This is the same thing as a perfectly polarized range in practice, and what I will almost always refer to. A perfectly polarized range means one player has the range of nuts and air, so he always knows when he has the best hand, whereas the player with the medium strength range never really knows because he always looks down and sees a medium strength hand, and he doesn't know what the opponent's holding. This illustrates why equity is not created equally. If a player has a range which is 40% the pure nuts and 60% air, how much equity does his range have? Think about this for a minute. How much equity does a range have if it has 40% the pure nuts and 60% pure air? 0.4 times 100% plus 0.6 times 0% equals 40%. So if you were to plug in that range to PokerStove, it would tell you your range has 40% equity, which doesn't look that good. Perfectly polarized ranges continued. But which range is better? The range with 40% equity and a perfectly polarized range, or the range with 60% equity and a condensed or only marginal strength range? So the term I like to use for a range that is the opposite of polarized, it only has mostly, bluff catching hands, medium strength hands, is a condensed range. So which range is better? One equity has a better distribution of equity, it has the nuts in the air, whereas the other range has overall more equity. And this is a question we're going to constantly be asking ourselves. It's a very important question. How do you deal with the fact that one range has a better distribution of equity, it has more nutted hands and more air hands, which are easier and more effective to play, yet the other range has overall more equity? Who decides what happens? So think about this for a minute. What do you think, in your opinion, is better? A range that has 40% equity but a great distribution of equity, or a range that has 60% equity but a poor distribution of equity? Think about it for a minute. It depends. Which variables are most important? Streets left to act, stack depth. That's talked about nonstop in my other videos. This determines pretty much how big of a deal having a polarized range is. And in reality, the 40% polarized range, the 40% equity polarized range will almost always be better unless stacks are really shallow and we're on the river. So mathematically, having your equity distributed well is a huge deal.